Hey there, and welcome to The Explainer. Today, we're diving deep into the code that runs your thoughts. We're talking about a hidden language that might just be shaping everything you see, think, and believe. So, let's jump right in.
So let me start with a question you've probably never really stopped to think about. What is the actual format of your thoughts? I mean, when you think the sky is blue, what is that in your head? Is it a picture? Is it the words themselves? Or is it something else, something deeper? It sounds like a simple question, but believe me, it is one of the biggest mysteries in all of cognitive science.
You know, there's this old idea called the language of thought hypothesis. The theory was, pretty simply, that thinking happens in a kind of mental language. But let's be honest, with the rise of modern AI and these massive neural networks, the whole idea started to feel a bit, well, old-fashioned, like a relic from the 70s. But what if that's totally wrong? What if that relic is actually the key to everything?
Okay, first up, the code of thought. Before we can see if this idea holds any water, we need to get clear on what a language of thought even is. So at its heart, the language of thought hypothesis, or LOTH for short, is the idea that thinking happens in what scientists call mentales. Now, this isn't English or Japanese or any spoken language. Think of it as a deeper, universal programming language for the mind. It has its own vocabulary of symbols that stand for concepts, and its own grammar, its own rules for how you can stick those concepts together to build a complete thought. So, what are the rules of mentales? Well, any system that qualifies as a language of thought has a few core properties, but let's just zoom in on a couple of really key ones. First, our thoughts have discrete parts, just like a sentence is made of individual words. And second, it has this thing called role filler independence. Just think about the sentence, the dog chased the cat. You can easily swap the roles and get the cat chased the dog. The pieces, the cat, the dog, the chasing, are the same, but their roles in the sentence totally change the meaning. Finally, this mental language uses logical operators, basically the mental versions of words like and or if, then. These are like the grammatical glue of our thoughts. All right, so if this supposedly old idea is for real, where's the proof? Well, let's start in the most modern, cutting-edge place you can imagine: artificial intelligence. Could this old ghost of an idea be hiding inside our newest machines? For a long time, the world of AI has been all about deep neural networks. And these things are amazing pattern finders, right? They just look at tons of data and learn statistical connections. This seems like the polar opposite of the structured, rule-based language of thought. But what if the most powerful thinking actually comes from combining them? What if you could take the logical grammar of a language and merge it with the awesome learning power of a neural network? Well, a really cool study from 2016 showed exactly that. Researchers gave different types of AI a pretty complex command, something like, show me the tallest object that is either blue or green. And the results were just crystal clear. The AI models that were built with those language of thought structures, especially those logical operators like or, they learned the task in a way that looked almost identical to how humans do it. That symbolic structure, it wasn't a relic. It was the secret ingredient. Okay, so it's in our most advanced AI, but here's where it gets really wild. This hidden language isn't just for super complex reasoning. It's actually running in the background during the most basic, fundamental thing you do. In fact, it's happening right now, every single time you open your eyes. It turns out this structure is baked right into your visual system. Cognitive scientists talk about these things called object files. You can think of them like little mental folders your brain creates on the fly to track stuff out in the world. And what do you know? They have all the classic signs of a language of thought. For example, you can forget an object's color but remember its shape. That's discrete parts. And in memory, your brain can accidentally swap the color from one object onto another, which shows that the property of redness is separate from the object it's attached to. And of course, your mind stores the abstract concept of a bottle, not just one particular picture of a bottle. It's amazing. Your visual system is literally writing sentences about the world in real time. Okay. This is getting pretty compelling, but what about minds that don't use spoken words at all? I'm talking about babies, or even, get this, insects. If this mental language is truly fundamental, it should be there too, right? Completely separate from any spoken language. And this brings up a really critical question. Can you actually reason logically if you don't know any words? Can a mind figure out that if a toy is in one of two boxes, and it's not in the first one, then it has to be in the second one? Using nothing but pure logic? Well, scientists came up with this really clever four-cut puzzle to test exactly that, and the results are just mind-blowing. It turns out 3-year-old kids can solve it, but what's even crazier is that an African gray parrot named Griffin not only solved it, he actually performed better than 5-year-old kids. All of baboons have cracked it too. This is just undeniable evidence of logical operators chugging away inside non-verbal minds.
And if you think that's wild, hold on. This isn't just for smart primates and birds. It looks like even bumblebees think in abstract concepts. So check this out. In one experiment, scientists taught bees to roll a little ball to a target to get a sugar reward. Later, when they gave the bees a choice of different balls, the bees didn't go for the ball that looked the same. They consistently went for the ball that was closest to the target. That means they formed an abstract goal in their tiny little brains. Even more impressive, bees can recognize an object by sight that they've only ever felt with their antenna in the dark. That proves their mental symbol for that object is abstract. It's not tied to just one sense. And that is a huge hallmark of a language of thought. So we've found this hidden language in AI, in our own eyes, in babies, and even in bees. So now let's bring it all the way home, to the part of our own minds that we usually think of as the least logical, our gut instincts, our fast, automatic System 1 thinking. There's this classic test for what's called belief bias. So imagine I give you this argument. All birds can fly. Penguins are birds. Therefore, penguins can fly. Now, the logic there is perfectly valid, but the conclusion is obviously false. You know penguins don't fly. When people are tested on this, they're actually a little bit slower to say the conclusion is false, because they feel the pull of the correct logic. It shows that your gut, your intuitive system, is sensitive to the logical grammar itself, not just whether the facts are right or wrong. And this exact same structure applies to something we hear about all the time, implicit biases. We tend to think of these as just simple, mindless word associations, right? Like peanut butter and jelly. But the research is showing they are way more structured than that. They actually seem to follow logical rules. Now, this is truly fascinating. Studies show that if you try to change an implicit attitude with simple association, like just flashing a group's name next to positive words over and over, it barely does anything. But if you give the brain a logical rule, even a totally made-up one, like if you see a green circle, then this group is trustworthy, the effect is massive. But, and this is the kicker, only when the if condition is actually met. It proves that our deepest, most automatic attitudes aren't just dumb associations. They're built on a logical if-then grammar. So let's take a step back. From cutting-edge AI to the way we see the world, from the minds of animals to our own gut feelings, the evidence for a structured, symbolic, language-like system seems to be hiding everywhere we look. So what's the final verdict on this supposedly outdated idea? Well, the authors of the paper we've been walking through today put it perfectly. They conclude that far from being some dusty old relic, the language of thought hypothesis is actually proving to be more flexible and better supported by the evidence than ever. Right now, it's simply the best game in town for explaining how minds actually work. So why does any of this matter? Because it completely reframes how we think about intelligence itself. It suggests that underneath all the messy, chaotic buzz of our conscious experience, there is a structured, grammatical, and deeply logical engine running the show. And understanding that engine is the key, not just to understanding ourselves, but to building machines that can one day truly think. Which leaves us with one final, pretty mind-bending question to chew on. If your thoughts are really written in a hidden internal language, are you a fluent speaker? And what incredible new things might you be able to think if you really learn to master its grammar? Thanks for joining us for The Explainer.